So, nice to meet you all. My name's Rachel. I'm a sales consultant at Tableau, based in the London office. And my role is sort of a technical role within a sales account team. So a lot of you will have account teams, and my role within that is helping customers get the most out of their Tableau deployment. This is my 6th TC now, both combining global and the European one. And I think my favorite thing about it, it's so nice to see so many people come together, share ideas, and build the community. So I just wanted to start off by saying a thank you to all you guys for coming and showing up and showing your A game. So I've been at Tableau around 4 years now, and in the past few years, I've been working on developing my understanding of the data science world and advanced analytics. And I'm really excited about the role that the Tableau platform can play in that, and that's what I'm going to share with you all today. As we go through the session, there's sort of 2 goals I want you to keep in mind. So, or things I want you to get out of the session, rather. So how can you use Tableau within your data science process? So I see lots of people really excited about this integration, but also many people struggle to implement it. So I want to show you that it's easier than you think to integrate, and show you some examples as well that might inspire you along the way. And the second thing we're going to talk around is how to deploy this at scale. How can we democratize the idea of data science to more people across the organization? So I think there's a really great opportunity ahead of us. At Tableau, we help people see and understand their data to make better, more informed decisions. And if we extend that to the world of data science, having more users involved in conversations, using powerful algorithms on the data, I think will just lead to much richer discussions across the organization and bring together groups of people that might be currently siloed across the organization. For the flow of the session today, the way in which we're going to integrate Python is using something called the external services connection. So I'm going to talk around why you might want to use this in the first place. Then I'm talking around how can we use Tableau in your data science flow. So I'm going to introduce you to what I'm referring to when I talk around the data science flow. We're going to do a little recap on how the integration works. So the idea of today's session is not to do a deep dive into the integration, but more I want to make sure everyone has the same base level knowledge before we jump into some examples. Then we're going to save the world with Python. Somewhat ambitious in under an hour, but I promise I'll give it my best shot. And then we're going to look at how we can scale this. So we're going to start off with a little bit of theory. We're going to save the world with some practical examples. And then we're going to look at how this can be scaled to help many more people across the organization. So why use external services? So thinking about this idea of advanced analytics, I think it's important to define what I mean by that. So if we think about different questions that you can ask to your business, typically we'll start off with, okay, what happened? What happened with my sales? What were my sales last month? What were my profit from these different categories? Very descriptive, and even Excel is really great at this. But then we start to progress and okay, I need to know what's happening right now. I need to make decisions right now. Or I need to know what might happen in the future. And then this is very much the Tableau world. This is what we're very good at out of the box. But we might want to start pushing that and start asking, okay, what can be done to make a certain outcome happen? So more prescriptive analytics. And this is where we need to start looking outside of what Tableau provides out of the box to supplement and complement that as well. Today we're going to be talking about how to integrate Python with Tableau. And to do that, we use something called TabPy. So TabPy has been available in the product since 10.2, and it's open source, and you can find out lots of information about it on GitHub, but that's the connection that we use. You can also use external services to connect to R scripts. You run R scripts and MATLAB as well. It's just all the examples that I have today are Python, but the concepts that I'm going to talk around, if your business codes more in those languages, you can apply the concepts to those as well. It's just all the examples of Python today. Okay, so what does Python bring to this party? So the many statistical and machine learning algorithms, they're ready-baked for you to run and use against your data. You can productionalize predictive models, so you can train your models on the data sets that you have currently and run it as new data comes into your business. So think of things like fraud detection or chance of customer churn. And as well, it's a programming language, so you have much more expressive power to be able to write whatever you like. So that's what Python brings. What does Tableau bring? So I think we have over 70 native data connectors now, and that's where we work with the end vendor to optimize the query that we're passing backwards and forwards. And you're not just limited to one data source either. We have cross-database joins, you can blend data sources, and as we saw in the keynote yesterday, the new data model is going to be really, really great. So you're not limited in different data sources. You can explore at the speed of thought, drag, drop, ask different questions of your business, and find out things that you never even thought you were looking for. The unknown unknowns in your data that come through this process of visually analyzing. And finally, interactive storytelling. So once you have something that you want to share with the business, you can put that into a Tableau story and guide your end user how you went through each step along the way to get to the final result. So I think bringing these together is a really great way to take advantage of both of the advantages that they bring. Okay, so the data science flow. What am I talking about when I talk around the data science flow? Well, as with all analysis, we're going to start with a question. And to answer that question, we're all data nerds here, so we're going to go out there, we want to get some data. We want to find our data to answer our questions. It might be dirty, we might need to process that, and then we can start exploring. And this is the world that typical Tableau users are really familiar and comfortable with. And even at this stage, it might generate more questions that you have to go back a stage, find more data, clean process, join that in. So this in itself is an iterative process, but one we should all be familiar with. Now, it comes to a point where sometimes questions can't be answered visually. And that's where we need to ask different questions. Maybe we want to predict a quantity, so we look at different regression algorithms. Predict a category, different classification models. We might want to group certain behaviors together and use some clustering algorithms, or improve data structure with dimensionality. But we can't do this on the data set in its entirety. We have to split it into train and test. If we test our model on the same data that it's trained on, then it's like having the answers to an exam beforehand. We need to keep them entirely separate. So we split our data out, iterate through, train our model, and then test it. And this might be something that gives us a result that we want to share. Or it might push us back a step and generate more questions. When we're happy with the final model, this is something that needs to be visualized, communicated with the business so that they can go ahead and make decisions off this hard work. But of course, at any stage here, you can push you back with more questions. So this is an iterative loop on its own, but equally, there's segments within it that you can go round and round. Now, I know it was data night out last night. Few saw heads in the audience, I'm sure. This is a bit of a scary slide right now. There's a lot going on. But I wanted to show you the intricate details, but I'm also going to refer back to this throughout the presentation. So I've made a nice little simple one for us as well. We can all take a deep breath, calm down. But this is a more simplified version of all those little steps that I just discussed. So, on to today's topic, saving the world. Now, we've looked at the theory. I want to introduce you to the topic. And for the next 45 minutes, I want to take you guys all on a journey of real-world data analysis along a single theme. So there's going to be multiple questions that come up, just like many of us deal with on a daily basis, and we're going to have to adapt, change, and keep moving forward to the end goal, which is insight. Now, the data sets that we're going to look at might be somewhat different than what you use on a day-to-day basis, but I want you to focus on the integration between Tableau and Python and think, how could it be adapted to work with something that you might have internally? So why saving the world? I think this is something that we're all becoming more and more aware of. 2 weeks ago in London, we had 2 weeks worth of protests in London recently by the Extinction Rebellion, trying to lobby government to take action about the climate change emergency. You guys probably all know this lady, Greta Thunberg. She's arguably a leader of her time at just 16 years old. If you don't know, she's a Swedish environmental activist campaigning, and her campaign has gained international recognition for things like the Fridays for Future. So youth will protest against climate change. And it's not just the younger generation, no. We have Jane Fonda as well. At age 81, she's been arrested several times now, taking part in Fridays for Future. So this is something that globally we need to take action on, and I think we're becoming more aware of as a big issue. So why is this something that I'm interested in? Well, I kept my introduction about myself at the beginning quite brief, but I love nature, and I've been really lucky to see some amazing wonders of the world. I studied a geography degree, I got my master's in geographical information systems, so environmental issues is something that's really close to my heart, and I thought if I can raise awareness while showing you some awesome Tableau integration, then I think that's a win-win. Okay, so we're going to start our data science flow now. We want to save the world. The theme is saving the world today. And one of the biggest threats to our environment right now is a rise in CO2 levels. So I'm interested in finding out, can we predict national CO2 emissions? And this takes us to our first step on the data science flow. I have to get my data. So I'm not in this business. I don't have any information on this. Where do I turn to? Well, I turn to my good friend Google. So I had to search and find, first of all, what variables could even come into play when I'm looking at this topic. What do I need to think about? So I found some research, and this is what I found. I found great information from World Economic Forum, different academic papers as well. Certain charities give loads of different ideas on what could be causing this. The most interesting one was a survey by the WWF. You fill in all this information about your personal life, and it tells you what a terrible person you are and what a strain on society you're becoming. But very insightful nonetheless. So I had an idea, okay, and now I know what variables I want to try and test. Like, I need the data. How do I get the data? So back to Google we go. Our World in Data had some really great data sets. I had things on Kaggle, which is a great data science website. Wikipedia, of course, and then there were some specialist websites along the way. So I had a lot of information now, a lot of data. So how do I even go about making sense out of all of this? Any guesses? Oh, you've all got headphones on. I can just pretend that you all said it. Tableau prep. So I'm not going to drill down into the flow itself today. It's not kind of in the scope of the session, but I will be sharing it afterwards if you want to take a look. But I took CO2 emissions at a national level for a number of different countries, and then 10 different things that I hypothesized to be correlated with it. And you can see I did many steps along the way, cleaned, processed, and joined together all these data sets to get my end solution. And the benefit of doing it in Tableau prep as well is that there's a logical trail written in plain English to show what I did to get from point A to point B. And these are the variables that we looked at. So everything from meat consumption and registered vehicles per country to that country's GDP as well. Now, before we jump in and take a look at that data, we're going to review the integration. So I know some of you might have even attended the hands-on sessions this week at Tableau Conference on the TabPy integration, but equally, some of you, this might be your first experience with it. So I want to take 5 minutes and just level set everyone's knowledge so that we're all on the same field going forward, but hopefully not overwhelm you. So what happens when we use this integration? So the first thing you're going to see me do is write a calculated field with a script function in there. The script function and then contains the code. Then we're going to send this to TabPy. So we send the code and the data along to TabPy, which is an external service, so it's not within Tableau itself. We send it to the external service where the code is processed and run. This creates a list, which is then returned back to Tableau. And Tableau displays this as a calculated field. So you'll see why it's important about the table calculations. It's brought back to Tableau and displayed as a table calculation, which means your compute using option is going to be really important. And we'll see that in the demo in a little bit. So let's look at some of the code itself. So as I mentioned, the first thing we do is define that this is a script function, and you have 4 options. So what we're doing at the very start is we're defining what response we're expecting back from Python. So you might expect a Boolean, a true or a false, integer, real, or string. So that's the first thing we have to do, is to think what do we expect to get back. Then we have this whole bunch of text in gray. And this is the Python code itself. Tableau doesn't evaluate this at all, so one thing to remember is you might get that nice little calculation is valid message, when in fact, we don't know because it's Python code and that gets evaluated by the external service. And there's something a bit special about this as well. We have a special reserved character, which is underscore argument. So if you have one variable in there, it's underscore arg1, and then this corresponds to a column in your data, a dimension or a measure in your data that gets listed just at the very end. If you had 2 arguments, it would be underscore arg2, and then it's just a comma-separated list of the columns that you want in the end. So this gives you a bit of an idea of the structure of how the calculations work. Okay. Everyone ready to jump into Tableau? Yes, many nods, like it. Let's take a look at our data. So now we're in Tableau Desktop, and I want to start looking at my data. First thing I always do when we're looking at a new data set is look at the number of records that we have. So in this case, we have 141 records, so I know that I have one row per country. There's 141 countries in my data set, so I already know what data set I'm working with. Let's look at this spread of this data. So we have CO2 for quite a few countries globally, quite a good spread of countries. And we can even take a look at what those emissions look like as a spread. So we can see that mostly they're coming from China, the US, about half as much as China, but the second one in our ranking, and then India, and then other countries following below that. So now we have an understanding of what the data looks like. We're going to jump in and look at a really simple example of a TabPy script. Now the first thing we need to do is establish a connection between my desktop client here and the TabPy service. So my TabPy service is running on an AWS machine. And what we do, we go up to Settings and Performance, Manage External Services Connection, and then we get this pop-up. Now we have to define what we're connecting to. So today's TabPy. So you can have R serve in there as well, but we're going to choose TabPy. And then you need the IP address and the port of where your service is running. Then we hit Test Connection, and we're successfully connected. So now I know that there's an established connection between my client here, where I'm writing my code, and the engine that's going to provide me the results. Now, what's the first thing? If anyone's done any online training for coding, any Python trainings online, first thing we do, what do we write? Hello world. So we're going to do the same in Tableau as well. Within my data set, I just have a column called hello world. It's just a string column. And we're going to use the TabPy functionality to put that as a label on the map. So if we have a look at the calculated field, you can see what we're doing here. I'm defining that I'm expecting a string as a response. I'm defining an argument, so p equals underscore arg1. Then I'm returning p, so I'm returning the argument. And then what is argument 1? Remember, we have to look at the very end. So it's here. It's just that column called hello world. And when we bring that into the view, we get an error, which is really fun because that means we can troubleshoot live on stage. So now we're going to jump over to my AWS machine where TabPy is running. So the first thing we should do is jump over to our web environment and make sure that the environment is running. You guys are getting a really good look under the hood today. Or maybe the very first thing we should do is check we have internet access. Which we may have appeared to have found the source of our issue. Is there anyone from the tech team that can help me with the Wi-Fi? going to take that as a no. Which one would that be?
Tableau conference.
Hmm?
We put a column in wireless. There you go.
Are we on? So we have Tableau.com. Ta-da! Easy, right? Right, let's give that one another go. We take our hello world script, put it onto label. Ta-da! So we've written hello world. Oh, you guys are very kind. Thank you very much. It's great that this gets recorded as well. And that my face is about 20 feet tall. So that's great. We've written hello world, but at the minute you guys just have to trust that I didn't just pull in the other pill, right? Wouldn't it be great if you could see that I'm a very honest and trustworthy Tableau employee? Well, we can. And this is a really great troubleshooting tip as well. As I mentioned when we were running through the code before, Tableau is always going to say calculation is valid because we don't evaluate the code. We just send it, and then any error messages you get back, we just pass through Python messages. So if there's something wrong with your code, a nice way to troubleshoot is to utilize the ability to print statements. So in this example here, it's the same code as we had before. I'm defining my argument, which is the hello world column. Then I'm printing a lot of stars, and then I want to print the column as well. So let's jump in, and I'm going to just swap the measure that's on label for this one that now has my print statements. And nothing seems to have changed in the view. But if I jump over to here, so this is the environment where my TabPy is running, my machine on AWS, you can see it printed all of those stars, and then we have 141 instances of hello world, one for every data point that we pass through. So this is a really nice way that you can troubleshoot what is being passed backwards and forwards, how far is the code getting before it fails, things like that. So you can utilize print statements, and it prints in the command line where TabPy is running. Now this is a super simple example, and we only have one dimension in the view at the minute. So as I mentioned before, it displays it as a table calculation, and compute using is really important. In this case, doesn't make too much of a difference because we only have one dimension. But say we were to bring continent in. So now I've colored the points by the different continents. We've got 4 of them: Africa, Americas, Europe, and the rest of the world. Now what we see, if we open our edit table calculation, we have some options. Now, if you're familiar with table calculations, you know that anything that we have ticked in these dimensions here is our addressing field. Anything unticked is our partitioning field. And in TabPy world, that means that for every partition in your data, we're going to make a separate call to the service. And I'll show you how that looks in the service itself. So we jump over, you can see now that we've got much smaller chunks of that hello world text and the different print statements of the stars. So here, we've made a separate call to the service for every continent in our data. Now again, with such a small data set, it's not too much of a big deal. But you can imagine a scenario where you might have a dimension with tens of thousands of values in. Think sentiment analysis or anything with like an ID field in. And if you're partitioning based on that in your table calculation, you're going to be making tens of thousands of calls back and forth to the external service provider, and that can hinder performance. So more often than not, second tip of the day is to make sure that you have all of the values ticked within your table calculation window. And that's going to mean that you only make one call to the service, send all your data, evaluates it, and sends it back. So you're only making one call. Now, of course, there are edge cases where you might want to make separate calls. Think if you're doing outlier detection or you want things to work within a certain cohort, you can utilize table calcs to your advantage there. But if you're starting out and you're seeing any performance issues, just check the way that your table calculation's computed and make sure you've got all the boxes ticked. Okay, so I think we're pretty much there. Everyone got to grips with the calculation? All understanding so far? Perfect. Let's take a look at our CO2 data. So we might want to look at our CO2 for each of our countries against a different variable. So say food consumption. And we can start to spot some outliers here. We have China at the very top, consumes quite a bit of meat and also has the highest CO2. We have the US over here, consumes a lot of meat but not quite as much as CO2 contribution as China. And then we have some outliers as well. So India is really interesting because it doesn't consume very much meat, but it has one of the highest CO2 contributors. So if we're thinking about, or if we're trying to define what contributes to the high CO2 emissions, even just from this visualization, we can see, okay, there must be something else that contributes because India is such a small meat consumer. We can be a little more scientific about this as well. We can add a trend line on. We can see there is sort of a trend. Or we can come in here and look at density, see if we can spot any further patterns. So we can see a few little hotspots within our data, but nothing too concrete. But even at this stage, we've done something wrong. So I'm starting to evaluate my data in its entirety. But remember, we need to do a three-way split. So I need to take my whole data set and break it down into train and test. So all of this evaluation just belongs in the test portion. And I have a column in my data set to do that. If I take my total number of records and show you the train and test split, I sort of have 99 to 42. If we do percent of total, you can see that gives us a sort of 70-30 split within our data, which is quite a respected way to split our data into train and test. So going forward, I'm going to filter this to only use my train. And this puts us in our second step of the data science flow. So we've got our data, we've cleaned, we've processed, we've split it into test and train, and now I need to choose my model. And I want to predict CO2 based on a number of variables, so I'm going to use a multivariate regression. If we go back to that visualization we just had, looking at meat consumption and CO2, as I said, we can start to spot some patterns, and they kind of look like they're correlated. But let's check when we filter out our test. So now we're just going to keep our train data set. We can see our values have dropped, and there still seems to be a bit of a pattern there, but I'd like to be more sort of scientific about this. And when I pull in my trend line in, the great thing about this is it gives us a p-value. So I can utilize the p-value that Tableau's generating for me. I don't have to write any code to build this and decide if it's significant or not. So the p-value is a value between 0 and 1 that allows us to determine the significance of our results. So the smaller the value, the stronger the evidence that they're correlated. And a good confidence interval to use is 0.05. So I could say here, if the p-value is less than 0.05, I want to include this in my model going forward. And Tableau's helped me to do that without having to write any code. In this case, it's 0.03, so this passes the test, and I'll take that through to my final model. And this can be repeated for the different 10 variables that we have. So here we have meat consumption, which we've already said is included. We have registered vehicles, which is strongly correlated. Same with landlines. And in fact, there was just 2 variables that didn't pass the test. Tree canopy cover didn't really seem to be too correlated, and air carrier passengers per capita. So I can remove them from this stage here and say I don't want to continue any further with them. So now for our analysis. So here we have a visualization with all of our countries in the view. And we need to filter them out now. So we've done our training, we're ready to test, so we need to leave just our test data set. But we can't just pull in the dimension like we did before, because the issue is here, if we filter it out, at the point in the order of operations where a dimension filter happens, it means we wouldn't pass it through to the external service. So you have to do something a bit clever. What we can do by utilizing Tableau's order of operations is create a table calculation. So table calculations happen at the very end of our order of operations. So we can use this knowledge and this understanding of how Tableau works to say, to filter out to just show the test data set, but the training data set is sent along with our model because it needs that to run in Python. So we bring this on and say, yep, I just want to keep my test data, and we have our leftover countries. Now this isn't the best looking viz right now just because China is so much of an outlier. So what we can do to deal with that is if we choose logarithmic axis, and I'm going to choose symmetric as well. I don't just want the positive values. But we can see we have a more visual distribution across our countries now. And we're ready to take a look at the multivariate regression. If I edit the calculation that I have already created, don't worry, I'm not going to go through this row by row. As already mentioned, a few saw heads in the audience, but I'm just going to give an overview of the structure so you can think of how you might want to put yours together yourself. We're expecting a real response. I'm importing the libraries here, so pandas and stats model. I'm creating a data frame, which essentially creates a table of all the variables that I'm going to pass through. Then I define my model, define my results, and return that result. And then all of the data frame is created of all these arguments that are listed down at the bottom, which correspond to the variables that we want to use. And when we bring that into the view, we can create a dual axis. So the green bars are my actuals, my gray is my predicted. Doesn't look very good, right? Now this is another tip around using dual axis. Something you need to remember is typically to synchronize the axes. So at the minute they're on two different axes, which makes it look like they're so out of skew. When we synchronize the axis, we can see them much more in line. And what I'm going to do, just so you can see those actual values below a little bit clearer, is I'm going to change this to a nice shape. And as we're working with CO2, we can use a nice little CO2 cloud. So we can start to see the distribution of our actuals against our predicted. And we can see it looks like it's kind of following the same pattern. But again, I want to be more scientific or more exact about the difference. So on the fly, I can quickly create a new calculation that takes one away from the other. And we call this our difference. And we can drop that into the view as well. So not only do we have the visual cue of our differences on the logarithmic axis, we can have the exact values as well. And the final thing that I want to do here, if we're sharing this with people across the organization, they need to know if they can trust my analysis and trust how it works. So I want to show them the R² value. Again, this is something we can do in Tableau without having to write any code. We can utilize Tableau's window sums and window averages to create the R² formula. And this is something that I can drag and drop just onto Tooltip. And the final thing to do, if this is something that we want to share with people across the business, we need to make sure that we're using terminology that they're comfortable with and that they're familiar with. So we can give all the details in the tooltip here. We can say what the difference is from that calculation we just made, and also add in the R² value. Make these stand out in a nice bold color. And when we hover over it, we get that information. So this is a much nicer way of, instead of saying R² equals 74.4, which would only mean something to a small subset of people, by using tooltips and put it in a sentence and saying, okay, 74% of the variability of the data is explained by the data, and the data is explained by the model used. So they know that 26% is contributed by something else. It's something that everyone can understand. Now this is just looking at sort of the state of play today, which is quite interesting, but I want to predict this into the future as well. How might this change going forward? So this is pushing me to ask more questions of my data. I had a final model, but I have more questions. So what if I want to look at what it would look like in the future, and also it's quite a dire situation to think about. So what would it look like if we change some of the things that are in our power? So this is something that I created in Tableau Desktop itself. I created some improved conditions. So for example, if I look at the future urbanization, I went online and found that it's likely to increase by 1%. So I can create on the fly new measures within Tableau. Now, future urbanization isn't something that we have a personal control over, but something we do have a personal control over is that the amount of meat we consume, for example. So if I show you this calculation, I did the same, so it's predicted to increase by 5%, but then I've applied something called a reduction ratio. So this is going to give us what it's going to look like in 10 years' time, but also gives us the opportunity to add a reduction ratio. And you can see that it's purple text, so this is parameterized value that we can use in the calculation. If I show you the calculation itself, you can see here it's a very similar formula. We're still expecting a real response. We're using the same models, but this time we create two data frames. The first one with the same arguments as before, and then the second one with these new ones. So argument 10 and onwards are the new ones that I've created on the fly. This allows us to train the model on our whole data set, so a whole 141 countries, and then test it on the same countries but with the new measures. So this is really great because we can utilize more data against it. We're returning our result, and then you see all the values listed here at the bottom. And that's what we have in the view here. We have all of our 141 countries with that predicted CO2. You can see at the top in red as well, I've put, so if we don't change any of our behaviors based on my model, there's going to be 842 million tons more CO2 in the atmosphere globally. But I can utilize this reduction ratio in the top corner to say, okay, maybe if we reduce things in our power by 20%, a 20% improvement results in 5,000 million tons less CO2 globally. So that's about the same as America's current annual contribution. And this is a really nice way to allow end users to interact with your models without having to know what's behind the endpoint there. They can happily enter information into parameters and do their own what-if analysis. This is something that can also be shared up onto Tableau server. So with a little bit more formatting, it might look something like this. And we can see what the reduction ratio is. They can come in here and maybe they're a little ambitious and say, I think I can do 30%. And we can see that would result in almost 7.5 million tons of CO2 less globally. You can even highlight a country, so we're in the United States today. We can see the values just for our own country as well. And another advantage of having this information in the web and sharing people in the organization is giving them extra contextual information, like in this information button. So if I've already said that 74% of the variability in this data is described in the model, 26% is due to factors that we haven't considered, as a business user who's maybe closer to the issue at hand, I can look at the variables being used and maybe think of other ones that haven't been included that should be. So this is how getting more people involved in the conversation suddenly generates more ideas and brings people together around this different conversation. So we've completed one full iteration of our data science flow. We communicated the results. We shared them with the business on Tableau server. But this has got me thinking. So we've explored how our actions can impact the CO2 emissions around us, but there's another side to this as well. So what about how CO2 emissions and climate change are impacting the environment around us? This has made me think of a different question and pushes me back to the beginning because I need new data to think of this. So I went back to Google and did some research. So everyone will be familiar with pictures like this, all too common. Temperatures in the Arctic are rising twice as fast as the global average. And sea ice cover is diminishing, meaning polar bears can't go out and hunt for food in the same way. Another horrific result is Pacific walruses started to assemble en masse on shorelines because there's not the ice out there for them to rest on. And this is really dangerous because the crowded conditions can generate stampedes and can be very deadly. But it's not just animals. So global warming is also the biggest threat to coral reefs, the coral reef ecosystems. And temperature rises are resulting in mass bleaching and outbreaks of infectious diseases. So in fact, more than 27,000 species are threatened with extinction currently. According to the WWF, global warming is likely to be the greatest cause of species extinction this century. So 1.5 degrees increase puts 20 to 30% of species at risk. More than 2 degrees increase, that's centigrade, sorry, we're in the US, I don't know the maths. But that will mean most ecosystems will struggle. So knowing that the predicted increase in global warming will have dramatic impact on global biodiversity, I want to use this data to investigate, can we predict threatened species? So I want to look at a number of variables and see if I can predict this threatened species. We're back at stage 1 again, so I have to find real-world data, process, and explore that. And of course, I use Tableau Prep to do that. So I found 2 main data sets, one from the IUCN Red List of global species, so that gives you attributes about a species and whether they're in fact endangered or not. And a second one, which was looking at the international trade of species, so where species are traded and for what purposes. Let's take a look at that data. So again, it's always helpful to look at how much data we're working with. In this case, we have 131 records, so 131 different species. And if we look at the train test comparison this time, we're working with a sort of 80-20% split. So let's take a look at some of those variables. In this case, I've already built them out for you to have a look. So these are different continuous correlations I looked at. So the size of an area where a species is found, the population of where it's being imported to, the urbanization of that area, things like that. So we have 1, this row represents species that are endangered, and 0 if they're not. And what we can see here is that the thing that strikes me most is that there's not really much of a pattern to pick out. There's a few hot spots here and there, but it's not really telling us much about our data. If we take a look at the discrete correlations in our data, now this visualization is a bit different. What we're looking for here is if it's a horizontal line, it's showing that there's not much difference whether a species is traded for that purpose to make it extinct or not. So we can see if something's traded for scientific purposes, doesn't really make a difference or not to whether it's extinct. But if there's a more steep line for hunting trophies, for example, we can see that 44% of species not being traded for hunting trophies are endangered, whereas 21% that are being traded for them are endangered, which was interesting at first, but it makes sense. If something's endangered, then there's going to be a lot higher restrictions on whether it can be traded or not. So these are just some of the variables we looked at. But the most striking thing here, as I mentioned already, is there's not really much of a pattern we can pick out. We can't find much insight in this. If I was given a random species in this list, I couldn't tell you if it's likely to be endangered or not. The power comes from when we put all of these things together and let the algorithm do the work. So in this example, we're on our second flow, we've chosen our model, and in this case, we're going to do logistic regression. The visualization that I have built out here, so we have a list of the species down on the left, and then a nice little paw. So a green paw means it's very happy, it's not an endangered animal. Red paw means it's endangered. So these are our actuals in the column that's there. So let's take a look at what the model would look like to predict this. So in this case, we're expecting an integer response. It's a 0 or a 1, a binary response. We're pulling in 2 libraries, the pandas model and sklearn, to use logistic regression. We're creating our data frame again with all of our arguments in there. We're training the model, and then we're returning our result. And we also define here which model we're going to be using, in this case, logistic regression, with all our variables down there at the bottom. So let's pull that into the view. So what we see here on the right is now the predicted one, and we can see a lot of green paws. In fact, there's only one that it predicts to be endangered, this southern right whale, and it was an incorrect one as well. So it shows that what we're using here, the model that I'm trying to use doesn't really fit the data. It doesn't make sense to use this. So what would be great is if we can add a way to be more flexible with the model that we're using. In this visualization here, it's the same as the one we had before. I have my actual results on the very left. Next to that, our predicted one, which is currently using logistic regression. Another column to say whether it was accurate or not, and then the percentage accuracy. So we can see using logistic regression, we're only accurate 48% of the time, which isn't really that great. But I'm using something a bit special in this calculation that's here now. If I open the calculation, well, you can see it's very similar to before. We still have an integer, but now we're importing lots of different models, not just at logistic regression. Everything else is the same. We're building the same data frame. We're getting the same result. But now what we have, where we were hard coding the model that we were using before, we now have a new argument, argument 16. And this is listed at the end here with our chosen model. What this allows us to do is parameterize, like we saw in the first example where we were parameterizing values and percentages, we can parameterize which model we want to use. And if I choose decision tree, this is going to recompute and give us a different result. And we can see here that it's 80% accurate, and it's a much more even spread of green and red paws. And again, this is something that we can share up onto Tableau server. Again, add a bit more context around it. You could add information about the model that you've used and allow them to interact. And also add a nice little touch, maybe a few pictures to give a bit more context. And we can go through and see which ones are accurate or not. So we have a false positive here for this fishing cat. Maybe one here for the lemur, tiger, and another one for the sand cat. So the sand cat is also predicted inaccurately. We've got a false negative. So even just having this and having visual cues, there's something that's standing out. Maybe I'm not very good at finding out when cats are within my model. So adding this extra context, these little additional touches you can have to include more people in the conversation. So we've now done two full iterations of our data science flow. So how can we scale this across the organization? Everything that you've seen me do currently, I'm writing the code within a Tableau calculated field. And I understand that within organizations, that's probably not the most ideal way to be storing your code. And in fact, you might have multiple people contributing to that code. Say the example that I just showed, you might have multiple people writing code, committing to a centralized point to use and run. Well, what you can do in Tableau using a command line is to publish this within the environment that's running TabPy. So you saw me show it before in AWS. You can host your models there, publish your models there with this a little single line on the command line. And then within your Tableau calculated field, it's just one line of code that you reference this model, this published model. So this is really beneficial because regardless of the complexity behind that endpoint, it's just referenced in this one line, along with the measures or dimensions you want to pass with it. So it's much more simplified version, and also you're not limiting yourself to have to update things in Tableau workbooks. It can be used across multiple workbooks. This is really beneficial for dashboard authors too. So there's many dashboard authors out there, they might not necessarily need to know the complexities of the model. Say it's someone in marketing looking at the success of their campaign. They can drag and drop in a Tableau pill that shows sentiment of tweets around a certain campaign. They don't need to know what's happening behind the scenes, but they can find a lot of insight by utilizing that as part of a published data source. So, a moment of reflection. What have we managed to do in the last hour? So we pulled together many disparate data sources in Tableau Prep. And this is something that can be easily picked up and utilized by different people. We visually investigated our data in Tableau Desktop, and we called out to Python to run advanced models. And we found insights that otherwise wouldn't be possible. And finally, we shared our results on Tableau Server so that other users can collaborate and discover their own insights from what we provide. So exposing data science in this way to people across an organization is a really great way to get them involved. If we reflect on our goals from the very beginning, hopefully now you guys feel more comfortable see that it's easier than you think to implement the use of external services within Tableau Desktop and Tableau Server and your data science process. And that it's really easy to deploy at scale as well, so many people can take advantage of the extensibility of Python and the flexibility of Tableau. So, what's next? It's the last day of conference. You guys get access to all the workbooks and presentations that we show this week, so I encourage you to take what I've shown you today, copy it, change it out for your own data sources, adapt it to your own business needs, and see what you can come up with. And from a more environmental perspective, if we all make small changes to our day-to-day lives, it really could make a big difference. There was a lot of more advanced topics that I glazed over for this session with regards to table calculations, order of operations, and different statistical methods. So if you want to deep dive more into those, there's been some sessions running this week. You'll be able to get those online as well. I actually now, if you could take a quick minute to complete the survey, and then I think we have sort of 5 minutes or so left to do Q&A after that. But I'd like to thank you for your time today.